Okay, kiddos. So today we're going to be talking about exponential functions and word problems. Now, whenever we talk about word problems, students tend to get freaked out because there's this conception that word problems are difficult. But I think that as long as you understand the structure of the word problem and how we're going to plug information from the word problem into our formulas, these aren't going to be too difficult.
Yeah, it's fun. I think most of us did word problems back in elementary school.
Cool. So what we're going to focus on today is what are the formulas you're going to use for these types of problems, and how do I know to identify the pieces that allow me to use those formulas? Okay, so today we're going to be focused on exponential functions again. This is what a basic exponential function looks like. F of x equals a to the x, where a is your base. That's the thing that remains constant. And x is your variable or your exponent. That's what can change, okay? So what we're going to do today is we're going to expand upon this. We're going to take this exponential function and we're going to add to it depending on what type of problem we're dealing with, okay? So today we're dealing with two concepts. The first concept is growth. The second concept is decay. So growth is when over time something gets larger. It's growing more rapidly over time. Decay is the opposite. It's where something's getting smaller. It's decreasing according to a set rate over time. So their growth, thinking bigger, okay, especially in the context of our word problems today, growth is talking about when money is growing or accumulating over time, when money is appreciating or gaining value by interest. And decay is when something is depreciating in value or when things are deteriorating, when something might be losing its effectiveness over time. Those are all key words that either indicate growth or decay. Now, based on growth or decay, there are two formulas that you need to know. Okay, so the first formula is this one. This is our growth formula. This is the formula that you're going to use on problems where things are growing, where money is increasing, where we have interest, or where we have appreciation. All of those keywords are indicating that something is growing. Now notice, you have 1 plus r that is now in the exponential function. So we have to understand what each of these letters means. Okay, A is the original amount, your principal, what you're investing or what you're starting with. Okay, so A is that original amount that you begin the problem with. The 1 is set, that's a constant amount. So 1, then a plus sign because it's growth. R is your rate of change. How fast are things increasing? The most important thing is you have to write R as a decimal. Normally, it's given to you as a percent. So things are increasing by 5% or 10% or 35%. We want to write that as a decimal. So we'll talk about, again, how to make sure we write that as a decimal. And then X is the time that's passing, usually in years, but not always. So like 5 years would be X is 5, 10 years, X is 10, stuff like that. Super easy stuff. Okay. Now, this formula is for growth. What do you think the only difference is in the decay formula? So what would be the only difference in the actual formula? There you go. So because decay is about things decreasing or depreciating or losing effectiveness, the formula is pretty much exactly the same, except now we have a 1 minus r in the parentheses. That's the only difference. Okay, so it's very important that when you read these word problems, you are determining if it's growth or decay, because that will change the formula that you're going to use. If it's growth, you make sure you use the 1 plus r formula. If it's decay, you make sure you use the 1 minus r formula. Okay. But A, R, and X still stand for the same things in each problem. Okay, we understand the formulas? Okay, we're going to be using these today for every problem. Okay, so we're going to get a lot of practice with this, even if the formulas seem kind of, general right now, and you don't really understand how am I going to plug numbers into this, we'll get experience with that. Okay, let's talk calculators. Okay, oh, sorry. Let's talk calculator. Now, this is an iPhone calculator. The iPhone calculator sucks. I would not recommend using it to do these problems. Okay, in general, iPhone, great tool. But the calculator that's native to the iPhone is not good. Now, I don't have an Android, so I can't really speak to that calculator. But what I can speak to is the Google calculator, which is very, very effective, and we all have access to that. So this is the calculator I'm going to show you how to use today. We all have access to it. It's free to use, and it's very effective. Okay, so if you have your own calculator, that doesn't mean you can't use that. It just means this is the one that I'm endorsing because we all can use this. It's effective and it's free. Okay, now we will get into that calculator use when we do these problems. Let's talk process. Okay, so here are the steps for doing word problems. Okay, the first thing we're going to do is we're going to read through and identify AR and X. We're going to write out our formula. So we have to determine growth or decay. We're going to use our calculator, and then we're going to interpret the answer based on the word problem. Most of our word problems today are about money, okay, but not all of them. So at the end of the problem, we have to determine, what does that number mean? Does it represent money? Does it represent percent of something left? Does it represent how much bacteria we have, or how much of a population we have? We have to make sure that we do that. Okay. Any questions about this? Okay, let's get into some examples. Okay, so here is our first example. So this is an example of growth. I'm telling you right away so that we can kind of look at this example and figure out what's the key word that's telling us growth. Okay, let's read through it. A principal of $600 is deposited in an account that pays 5% interest compounded yearly. Find the account balance after 4 years. Okay, now that sounds like a lot, but really we're only looking for 3 things here. Okay, a principal in this context, principal stands for the amount of money that someone invested, not like a principal of a high school or anything like that. It stands for how much money did they put into the account. So if they invested $600 to start with, what letter does that stand for? A. So A is going to be 600. You don't need to write the $sign down because we can't put that in a calculator, so just 600. Okay. The account pays 5% interest compounded yearly. So 5% interest, that stands for R. But remember, we can't put a percent into a calculator, so we have to convert that into a decimal. So I want you to think about percents like pennies. If you had 5 pennies, how would you write that down? So 0.5 wouldn't be 5 pennies, that'd be 50 pennies. So what's 5 pennies? 0.05. Okay, very, very important. There's a big difference between 0.05 and 0.50. Okay, so remember, to convert a decimal, or sorry, a percent into a decimal, think about pennies. 5% is just 5 pennies, like 5 cents. Okay. Now, the last line, find the account balance after 4 years. What does 4 stand for? X. Very good. Okay. This is a growth formula. So our formula is A1 plus R to the X power. So let's write out our formula. A is 600. Then I have parentheses, 1 plus 0.05, and X is 4. That is the thing that I'm going to type into my calculator. Does that make sense? Okay. So let's go to our handy dandy calculator and let's make sure we understand how to type this in. So it's very, very simple. We just type it in exactly the way we see it. So 600 Then we hit the parentheses button. 1 plus 0.05. We close the parentheses. And then to get the exponent, it's the button down here where it's x to the y power. Does everyone see my mouse on the button? You hit this button and that makes an exponent, and our exponent is 4. Then all I do is hit enter. Now, just like money, we are going to round to 2 decimal places. So $729.30. 30 cents. Okay. Everyone good on how we got to the 30 cents? 2 decimal places? Good. Okay, so our final amount. So after 4 years, we have $729.30 in our bank account. So remember, interest means you don't have to do anything to the amount of money, but over time, it grows. That's what interest is all about. Okay. Now on formative for your homework tonight, you do not have to type in the dollar sign. You could just type in 729.30 and that would be the correct answer. Okay. If you leave the dollar sign off, I'm not going to take points away. Okay. But I put the dollar sign there so you understand that this is about money. Yeah. Question.
When it gets to like a big number like that, where should we add?
So 2 decimal places, just like regular money. So that's why we stopped at 0.30. Okay, cool. Really good question. Okay, kiddos at home, any questions about this first example? Okay, let's try another one. So again, this one is about growth, but I'm going to have you guys kind of walk me through this one. So I'll read through it. A principal of $300 is deposited into an account that pays 7% interest compounded yearly. Find the account balance after 10 years. Okay. So what does a principal of $300 stand for? A, very good. Okay. The account pays 7% interest. What letter would that be? Okay, so again, R, very good. 7%. How would I write that as a decimal? Very good, 0.07, perfect. Okay. And then find the account balance after 10 years. What does 10 stand for? X. Very good. Okay, this is a growth formula. So A, 1 plus R, because it's growth, to the X power. Okay, so let's plug in the numbers. A is 300. 1 plus 0.07, because that's our R as a decimal. And then X is 10. So that's what I'm going to plug into my calculator. Okay. So we started with $300. And according to the interest, so 300, and then we have parentheses, 1 plus 0.07, close the parentheses. And then our exponent, remember this button right here, exponent is 10. So starting with $300, after 10 years, we will have $590, and then we're going to round up to 0.15. Now, why am I rounding up to 0.15? You guys remember how we round? What number comes after the 4? So when we have a 5, that means we round up. Okay. So we are going to do 590.15, not 0.14. Exactly, $590.15. Now, what if this was 1, 4, and then 3? Then it would be 14 cents. Okay, so whenever you look at the first 2 decimals, right, the first 2 places, you look at the third number. If it's 5 or bigger, you round up. If it's 4 or lower, you round down. So 590.15.
So if you use a number, even if it wasn't like 4, like, let's say that thing was a 3 and
Then it would be,
4.
you round up to 4.
Yeah, like okay.
Okay. Just in general.
The number after it's like
Mhm.
Wait, now, hold a second, just, making sure here, but, so, what we have did 15 cents before, right? We don't round up after that. It's find out.
Nope, you don't. You only round up because we're going to 2 decimal places. You round up that last number. You don't round that up to 20, right? Only round up to the 2 decimal places. Okay, we've done 2 examples of growth. Let's look at an example of decay. Okay, so remember, what's the difference between growth and decay?
Growth is where you add, decay is where you take away.
There you go. Growth is where you add, decay is where you take things away. So you buy a used truck for $40,000. I know that's expensive. It must be a really nice truck. The value of the truck decreases. Decreases is our key word here. Each year by 8%. Estimate the value of the truck in 5 years. Okay. So you buy a used truck for $40,000. What does 40,000 stand for?
Okay.
Good.
Seriously, no, that's a lot.
The value of the truck decreases. Decreases is your key word. That means it's going to lower in value each year by 8%. What does the 8% stand for? R. Now 8%, we want to change that into a decimal. How do we do that?
It's 0.08.
0.08. Very good. Okay. Estimate the value of the truck in 5 years. So 5 stands for X. Now remember, this is decay. So our formula is A, 1 minus R to the X power. Okay. Let's plug in numbers. 40,000. 1 minus 0.08. And then X is 5. Okay. So the truck started at $40,000. It decreases in amount 8% each year for 5 years. Let's see how much it's worth after 5 years. Okay, so we have 40,000. Then we have parentheses 1 minus 0.08. And then our exponent is going to be 5 because 5 years. So 26,363.26. The number after 6 is a 0, so we just keep 0.26.
So please, like, can you- 6,000.
26,000. Then we have $363.26. That's how much the truck is worth after 5 years.
Huh, still a good amount of money.
Still a good amount of money, but not a very good investment, right?
Yeah.
Okay, after 5 years, it's
Yeah.
almost
And I'm
decreased
pretty
by
sure
half.
Many people would just con it out saying like, still charge it. Like when people say, but didn't this kind of, and it's like, yeah, but it costs like,
Yeah.
but it's basically worth.
And I
a
mean,
lot.
doesn't mean you can't sell it for more. It's just
Yeah.
that's what the value would be. Ty, question.
So I got a different answer. I got 26,000.
There you go. There you go. You got to always make sure you're typing in the right equation.
Yeah.
But good job checking.
That can actually happen to, it happens to so many
Very
people.
easily. Okay. So does everyone understand how we got?
Yeah.
Okay, let's try another one. So this is another decay problem. Okay. So a radioactive substance is decaying at a rate of 4% each hour. So we're taking it straight to like a chemistry problem. Okay. How much of the original substance is left after 6 hours? So this one's a little bit different. Let's go read through it again and make sure we can find our letters. Okay. A radioactive substance is decaying. Again, that's a key word. Obviously, this is a decay problem, so it's getting smaller. At a rate of 4% each hour. So what does 4% stand for? Okay. Now 4%, how do I write that as a decimal? 0.04, very good. How much of the original substance is left after 6 hours? That's good. So we have 6 hours standing for X. Now, this is interesting. We don't have an A in the problem, so we have to think about this.
Yeah.
At the beginning of the problem, what percent do I have of the object? I have 100% to start with, right? Because it hasn't started decaying yet. So A is going to be 100 because that's how much we're starting with. Right?
So if it hasn't said what number decays in,
Then you start with 100%. Because remember, the context of this is how much percent is left. So we're starting with 100%.
so
Now, on your quiz on Wednesday, you will not have a problem like this where you have to kind of assume what A is. I'll make sure it's very explicit, okay? But on this problem, we're assuming that we're starting out with 100% because that's how much we start with the substance before it decays. Okay, so again, this is a decay problem. So A1 minus R to the X power. Let's plug in our numbers. We have 100, 1 minus 0.04, and then X is 6. Okay, let's take that to our handy dandy calculator. So see how much we have left. So remember, we're starting with 100%. Over time, it's decreasing by 4%, 0.04 each hour. We want to know how much is left after 6 hours. 78.2. And then what am I going to do with that? I'm going to round it up. So 78.28. So I have 78.28% left.
so basically $70.
Well, this isn't money anymore. Remember, this is how much of the item is left. What percent of it is left? Exactly, 78% of the toxic chemical,
Yeah, I'm pretty sure not that those people would want to have toxic chemicals.
right?
I mean, most get dumped into an ocean, and I'm pretty sure not many people want their kids to swim around somewhere. and-
Definitely not. We don't want that.
There's a lot of stuff like that happens.
Yeah, definitely. Okay, so these types of problems, you're gonna see one of these on Wednesday. Okay, so really, really